Yeah, okay, maybe we'll start.
Until missing one person. No. So I'm still adapting to how to do this. So like I'm trying out something here. Just to clarify before I start, do you have any, like if I talk bad about this paper, will you get mad at me or something? No? So, because in my personal opinion, this is not a good paper. Like it's covering more or less a relevant area, but what it's doing is a bit lacking. But anyway, first I can talk about what the paper is more or less before that. Has anyone read it? No, save yourself for that. Like they talk about here applying the Scrum methodology to an open source ongoing development process, because the team here found a project which is an open source software Java tool which does something generic that doesn't really go into that much description. But when they came into it, they sort of were doing it in more or less the waterfall method, like planning everything and then designing everything and doing like no iteration and nothing from Scrum or Agile at all. So they were looking at adding it, and more or less, is it possible to switch to Scrum in an ongoing project, even open source? And then is it possible to apply Scrum when the developers are geographically distributed, like people are not working together, which is really common in open source development. They also wanted to look at if Scrum helps improve the quality of the product and the productivity. And well, more or less, if you just skip to them right away, they conclude on all these points that they've proven that it works and it's fully doable. Like it's possible to switch to a Scrum in an ongoing development process. I don't argue with that. That might actually be true. And they also say that it's possible to apply it to a geographically distributed team, even though their way of doing it is kind of questionable, but they can come back to that. And then again, they also say that with Scrum, they obtain high quality code quality without changing things too much, and that might actually be doable. And this is done for their project, which is called MaxIXIM, which this is done 5 years ago, and all references I could find to the original project is that doesn't seem like it's being worked on or even exists anymore. And just for the sake of it, the original development was in Italian, and it's really hard to dig in Italian, especially since all the references to the primary repo and everything seems to be dead. But let's go to the top here. And they have several different metrics for showing it. I'm going to get back to that because, in general, the paper is they're looking at applying this to an open source software development team, which make it seem like this is a huge team with a lot of contributors and a large core team. No, it's 3 developers with no external contributions. I wouldn't even call that open source project. Even like the code is open source, but they have no contributors outside. Well, at least not everyone I could find. They talked here about the amount of developers switching between. Yeah, here 2, 3, 4, 3 developers. This is not a large project, so this might not be generalizable to larger projects. Like they are doing, as far as I know, they're doing Scrum in Moodle, but let's imagine you want to, before they switch to Scrum in Moodle, want to say, hey, look at this paper. We can do this in Moodle as well. That might be really risky. That might not be the best decision without further testing and sources. And then again, like the paper has a bit of bad English, but I certainly understand it as it's from an Italian. So not to bash the Italians or anything, but like people not having English as their native language or forced to have it as a secondary, as in Norway, tends to have a bit bad English sometimes. But then again, like there's a lot of countries, like in France and Germany, that actually code in their native language as well. So it might go to us sometimes. But yeah, there was a small team which met up around one time a month, which seems like actually is a good idea. Where like if you have a distributed team, they need to meet at certain intervals and talk to each other and meet, like you guys did last year in Helsinki. I can't remember. Yeah, and that seems to be working. And the way of doing the stand-up meeting with this distributed team is having a forum where each morning the Scrum Master creates a new post there and writes what he's done, and everybody adds a response onto that on what they have done. And it seems to work more or less, but I think it should be more real time than that. It works with a forum and everything, but it's sort of a bit disconnected. But they talk about it as a really good solution here at least. And then again, they're not using the standard way of formatting scientific papers properly either. Yeah. And this is a case study of one example, which might not be applicable to different kinds of tools. There is no information about what they did, how they did it, just general stuff, so it's not reproducible, more or less at all. Well, at least not in the same manner, even close. But then again, they have a lot of background on talking about how Agile works, and then again, this is 5 years ago, so it was a lot newer back then. And it's an interesting read if you want to know about one case study, but then again, like it might be a bit too narrow, and if you dig a bit into it, it might be actually they're influencing the results a bit more than they expect to do. Because like, in order to know if it's possible to apply this to an open source project, we first need to have a short time span before they apply it to see how it worked before. But if you look into data, it seems like by them measuring the code quality, the developers started to improve their code quality, even though they still did waterfall method. So the data might not be that accurate. I can go more into detail, but I think
maybe just talk a little bit about their quality indicators that they were. You mentioned a little bit that you can come back to the indicators. Quality indicators. Question of whether these are good or not.
Oh yeah, by the way, this is the Scrum board where I posted each day, but not all of the developers responded each day either, so it was kind of a mess. And like posted there, but then again, nobody speaks Italian here, as far as I know, so can't really determine that. So here I talk about like what you're looking for. You're looking for how well the code is organized, how fast people are using, the quality of the code, and like, for example, how many comments are in the code. And all of these metrics was kind of low in the beginning. So switching to this more iterative style and everything, in addition to like giving me a new way of doing it, actually improved a lot of metrics. But then again, they might improve a lot of these metrics just based on the fact that someone is writing a scientific paper about them. So they sort of get their act together. And also looking at how sprint effectiveness, but you can't really compare that one to earlier in the waterfall. Can't really compare waterfall sprint.
And that was the one I was surprised to see how they define sprint effectiveness. So they counted the percentage of user stories carried out in each sprint period. I don't know whether that's effectiveness or not.
Yeah, all of the metrics doesn't seem like the best choice, and I can honestly understand all of them either.
But the other ones were more known, but the sprint effectiveness was kind of a strangely defined one.
Yeah.
So at the end of the studies, they switched to Scrum, or they continue to use waterfall?
I can find the one here. Yeah, here they switched to Scrum, and this is earlier. Like this amount of more or less warnings in the code. And here in the period where they checked, like here they're still using waterfall, and you can see clearly that they improved their code thing a lot when people were measuring them, and then they switched to Scrum. But you can say that Scrum improved the amount of warnings they received at least. Whereas it took more time iterating, looking at the code, fixing things, not just pushing things to that. Seems like in this pre-Scrum era, they sort of just, is it working at all? Is it compiling? Sure, it works. But when Scrum was introduced, they focused more on fixing errors rather than just pushing them back and forgetting about it. And then again, not all of the sprints were successful either. But strangely enough, they actually got worse at it as time passed on. Yeah, and for the last that they actually expected further process to improve by all measures. So they expected this to continue to improve after the finish of this, even though they more or less heading towards the release of it. And as far as I know, it died out not too long after the paper was finished. But they couldn't really find any reliable source of that.
So just a short comment about these projects. You find these kind of projects in the literature every so often, and there are usually one or the two reasons for these kind of projects. One is that there's a PhD student, and the PhD project typically 4 years, 3 to 4 years. And the PhD student is active and developing and publishing, and when he's done with his PhD, he gets a job somewhere else, starts doing something else, and then the project stops. And the other will be European projects. As long as they get European funding, they get running, and once funding stops, project stops. And this is, you can see, it's been supported by the Calypso EU third framework or sixth framework project. And when the sixth framework is over, and if they get a seventh framework project, then it stops, because an EU has been a bit, not what the right word would be, but they have been disappointed to see this project, these big research projects, and when the funding stops, the project stops. And so later, the 2020, Horizon 2020 projects, they'll be focusing more on projects that would actually deliver something to the communities, not just a research project that ends up with something, but it's supposed to end up with something that is going to be actually used. So it's more focused on the user part of the story than the research results part.
Yeah.
I think that explains this. So this is kind of a EU project that had funding for some time, then they were active, and after funding stops, they didn't continue, weren't able to secure other funding, and then the project stops.
Yeah, and this paper published 4 days ago sort of more or less covers the same subjects, which is a really interesting read depending on needs. Like this talks a lot about how academic sort of focuses a bit too much like the amount of papers published, and like they just do and done, move on. So you talk about there.
Okay.
So next one.
Next paper is.
Can I use the laptop?
Yeah, sure. I can look for you too. Yeah. Also the one just mirror. Easier to do this. Mirror?
Yeah.
Yes, yeah, just press S.
Yeah, so this paper looks into this or challenge the axiom that agile methodologies cannot be used in safety critical systems. So they say that indeed the agile methodologies for Scrum can be used in those kind of systems. Safety critical systems are systems that, for example, this is surgical toolkit. If there is an error in the back, a person can die. Or there's an example of automatic brake system. So if the brake does not stop, somebody can die. And as they begin the paper with saying that it's like commonly understood that agile methodologies are not focused on documenting, so that's why they're not suitable. But then, as their argument is that agile technologies methodologies are very flexible, and they, for example, if you need more documentation on the project, then you can add more documentation items in the backlog. So the system that they are taking as an example is called Image Guided Surgical Toolkit. So basically, it's a framework that you can create an application for a certain surgery on top of it. Yeah, they get some background about who has, like, this Boehm's guy. His argument is that agile is not suitable for this kind of systems. But yeah, they go back and forth and saying that with a waterfall you need to have all the requirements ready at the beginning and to plan for everything, while agile is kind of recognizes that the knowledge can change and circumstances can change, requirements can change, and they're running into sprints usually. These guys, I think they have two. I'm not sure how long, but it's a relatively short sprint, and that you can see what went good, what went bad, and then act upon it. The thing is here, they get some general studies that say that implementing agile technology methodologies help them, but they're not really into the area of surgical toolkits. So yeah, I'll not go into details. I did not find them relevant at all for this project. So as I said, this is an open source framework, so you can create surgical application on top of it. And yeah, they say that agile is really suitable for them because they don't have the requirements up front. So it depends on what kind of surgical application you will do, then you will know the requirements. And as they say, there are many components, like robotic arms and needles, and I'm not an expert into how operation is done. So yeah, they give us, they say they recognize some practices or best practices, and few of them are, so the people that are working on the project are really important, and the skills they have and how they communicate with each other. For example, these guys are using wikis, so they are on the same page on what's happening. Yeah, so using agile methodologies, you have this, like as we do sprints, and after the end of the sprint, they are gathering together and deciding what code is suitable enough to go to the main code repository. They're putting huge emphasis on testing and having 100% of the code source to be tested. They were using automatic unit tests. And yeah, they talk about displaying all the, how many tests failed, how many tests succeed on the dashboard, and using some open source like C-Dash or CMake. And yeah, as with every sprint, you're only focusing on what's in that sprint. You don't focus on the backlog or anything, just what the issues of that sprint are. Yeah, so again, testing, And this is, they say that with Agile, every bug, or almost every bug that is found or reported from the previous sprint can be fixed in the next one, because it's a iterative, and the sprints are pretty short. Yeah, and they end up the paper kind of sadly, because they say assessing the safety of this system is difficult because it's a framework and not a specific application, and the whole paper was kind of is it safe or not. And there's another one. They say that they acknowledge that the agile approach is neither as rigorous nor as complete as it could be for safety critical domain. So yeah, they spend 18 pages claiming something, and then they say we need more stuff to do. So yeah, basically that's the paper. Has anyone read it? Probably not. Yeah.
The paper isn't so much about global. It doesn't mention global at all.
Yeah.
That dimension isn't there. But the interesting thing, I think, for a global setting is that, and we talk about it next time as well, is when we come into applications like this where testing is important.
Yeah.
Then the question is how easy it is to do good testing in a distributed global team. So from that perspective, not all agile projects are the same. The same as we saw last time is that there are some projects are easier to manage, and they are because they are simpler. They tend to be more successful in a global setting than the more complex one. This is on the more complex. So yes, it can be done, and even with some disclaimers. But then the question is, if you try to make it global, will it work very well then with all the complexities and the mission critical or safety critical features? So I think it's I interpret as a paper saying that for safety critical applications, you should probably not think of doing it in a global.
Yeah.
That's the first choice. Yeah, probably not, because what they say here is it is more complex, and even though they did test, we didn't really have, as you said, we didn't have the convincing data saying that this is definitely as good as. Very well. Okay, thank you. And then 2 short and 1 longer paper.
Yeah, yes.
Let's find a computer.
Eller kanskje noen. Er det noe som har lyst til å låne her, kanskje?
Er det DisplayPort til HDMI?
Ja, jeg tror vi har den i her, men det er DisplayPort her.
Okay.
VGA-port. Det blir DisplayPort.
Nei.
Dette er
Ja, du kan låne bare en fin i verste fall. Altså.
brukte vel bra i gamle dager, det var VGA.
Ja, du har VGA, ok, da funker det.
VGA er sikkert ikke.
Men hvorfor ikke HDMI på eller?
Nei, det kan du spørre om. Det er gøy. Det tar, den der er sikkert, det skulle vært kanskje nytt for 5 år siden sikkert, så det tar litt tid. Det er et virkelig godt spørsmål.
Ja, jeg skjønner ikke hvordan det var. VGA i nybygget også.
Ja, det kan du si. Ja. Jeg hadde budsjett for å bygge nytt, men ikke budsjett for å skifte all infrastruktur for øvrig.
Ja.
Så det ligger noe der, altså.
You're all doing the paper together.
What?
Don't start it.
Okay, never mind. Da må du ringe Maria.
Ja, skal vi ikke spørre. Tror jeg.
Yeah.
Okay. Can you sign in on your Skype? Do you have her on Skype?
think so. If you have the last conversation we did together, the last conversation we did together.
Yeah.
Should probably there.
I'm not sure if you can call her because that depends on the privacy settings instead.
But I can tell, I'm speaking with Mariana, so I can tell her to accept.
Okay.
Yes.
So that's one of the measures they make to go.
If you connect to the, I think if you connect to the projector, you're probably going to get the speakers there.
Did I know?
Yeah.
Do you hear me?
Yes. Do you hear us?
Yes.
Good.
Oh, so I'm standing up there on top.
Oh. What's up?
You ready, Maria?
Yes.
Sure, I can take the
Then we can start.
Me?
Yep.
Okay. So I will talk about first paper proposing a software process model for follow the sun development. Follow the sun development is an alternative for global software environments when trying to manage problems related to temporal distance. Its main purpose is to reduce software development lifecycle duration or time to market. It is uniquely focused on speed of the development. But while follow the sun concept looks promising in theory, it appears to be difficult in practice. That's why authors proposed a new software process model for this follow the sun development concept. In this model, they're using such term as handoff. These terms defining a transition process from one side to another. Handoff is happening at the beginning and at the end of each working day shift, and it presents a status update and to pass an unfinished task from one side to another. On next slide, you can see first and second versions of this software process model. From these two versions, authors come with third one, the last one, and these two versions also consist of the same steps as the last one, so there is no need to explain them. And we can go to the next slide, which shows which step consists software process model. Its first three steps is team setup, project planning, and communication protocol. If you look onto the model picture, you can see that from start we are going to first step, which is team setup. It aims to identify available sites and allocates human resources for the project. It is important to verify if there are staff, cost, or scope restrictions in each site. On this step, when the project is defined, it goes to the next step, project planning. Project planning developed by project manager. And next 3 steps, communication protocol, cultural training, and task allocation started in parallel, following the second step, project planning. So communication protocol defines communication resources and the schedule for synchronous communication between sites. About next steps in this model, will explain you, Hakon.
Yep. So the next step is cultural training. It's pretty much that you get the teams together and build trust. And it should be done, or they suggest that it should be done multiple times throughout the project. The task allocation would be the next step. And it's pretty much that you find what tasks should be done that day, and yeah, and then you move on and you carry out the work. Carry out tasks is pretty much very dependent on the organization, so they don't go into that. But at the end of the day, they then do the handoff session, as Maria talked about, and the next team starts to work. Yeah, I think that's good. In their conclusion, they have some recommendations for this. Where project planning should be done after team allocation, because in team allocation you might need to move some people around. Also, in communication protocol, they specify that you should look at your team and see what temporal and cultural diversities there are before actually choosing what communication tools to use. For the cultural training, they also suggest that by building trust, the less experienced people will actually become more experienced, because you can start communicating with other team members, asking for help and stuff like that, because you have trust in them and you start to understand what they're good at, and yeah, and so on. They end with those 2 last points, that with this model they try to bring theory and practice closer together, and they really believe that their model is. Thanks.
Okay. So the next paper kind of continues the work, or they explain like the basics behind the model, and they want to validate it. As they just mentioned, the model contains of 6 sub-processes, which is based on 25 best practices. And these best practices are based on literature and lessons learned from case studies. And to validate the model, they used 20 experts from the IT world, multinational expert panel, with some up to 20 years of experience within global development. Yeah, and what they did is they classified the best practices into different sections I'll show you later. So the goal of this study was to gather the view of experts about the applicability of best practices included in the sub-processes for follow-the-sun projects, and to gain an understanding of how best practices included in sub-processes can support FDS projects. As I just said, the expert panel was multinational with up to 20 years plus experience. And also the experts had to deliver real life evidence to support their view on the best practices. And yeah, and there was also done a questionnaire, which there were 2 questions per best practice, and that was distributed through all the experts, and they were split up to into 3 sections, which made a total of 192 answers, and they analyzed these answers to put the best practices into 4 classifications, which you can see there: valid, partially valid, context specific, and inconclusive. Here you can see the sub-process communication protocol and the best practices found. And just an example, there were 25 best practices. I'm not going to go through all of them. But here you can see an example of how they look. Like the top one, daily exchange of the project status and by technologies, valid. And then we can go that to partially valid, which is calendar of offline sessions should be clearly defined. And context specific, clean handoff and stocky handoff interactions. I'll explain exactly what this means. So valid means that like the expert panel where they agree on this is a valid, this is a good best practice. Partially valid was like there was some like discussion about it, some pros and cons, and then you have context specific, which kind of it lies in the name where the best practices are good in specific situations. And then you also have inconclusive, which means that they meant there was not a best practice and not best practice. And as you can see in the result on the bottom there, they found no inconclusive best practices, which is kind of weird. And also they said that it was they came up with 25 best practices, and I saw some of the best practices and they said they were numbered from like 1 and all the way down to 31, I think I saw. So it's kind of weird. There was some skipping numbers in there, so it's weird that they had no inconclusive. So I'm not sure what happened there. And you can see all 50% was valid and partially valid and some context specific. So they concluded with that it had their study had the practical implication for organizations that want to implement FDS, and organization will benefit by having access to the list of most relevant best practices. And in the future, they would like to extend the classification approach for sub-processes and the SQL flow between sub-processes. They also would like to map the recommendations given by experts in order to improve the model structure. Yeah. So they also mentioned some author bias, which kind of led me to think that there's something weird because they found there were no inclusive, as I mentioned, there are no inconclusive best practices, and still that they like the number list don't add up. And they mentioned that there's some author bias, but they say that some other had been reviewing their data and approved it and stuff, but it feels kind of shady, but I'm not sure. But I think that's it, yeah.
Maybe a couple of comments to the 2 papers collectively. If you go to the model, that model, what is called the sun specific part of the model? I mean, compared to any global software development project?
So I think what I associate the main part about this model is to make it possible to for global software development with 2 teams in different time zones. So this kind of means like one. It's, as you can see on the bottom here, it's split into shifts and working days. Where like let's say that the first shift starts and they work through the day, and then when the first shift is done, then somewhere else in the world another shift starts, which then when that shift is done, that concludes the working day as I see it. And this means that through one working day, 2 8-hour shifts can be done because of the different time zones.
Because to me, everything to the left of the yellow square would be what you have for any global software development. So what's specific it would be that the granularity of issues. I mean, the granularity of communication, the granularity of interaction would be much higher when you need to coordinate per day. Because what you need to hear is to coordinate per day. I mean, if this had been a non-follow the sun project, then you need to coordinate, but you don't need to coordinate every day. It might be okay to coordinate every 2 weeks by end of sprint or whatever. But in this case, you have this very, very rapid. But other than that, I mean, many of these best practices would apply for any global software development projects. It's not specific because I mean, anything that has to do with handoff would be specific, because then you basically give the project over to the other team and you expect it to get it back next morning. So that is a specific part. But other than the handoff, most of these best practices apply to any project. And with less, I mean, the granularity will be different. You don't need to communicate that frequent because you're not going to be continuous. You don't need a half an hour every day to coordinate with the other team because you don't need to be at that granularity level. Okay, thank you.
No, I haven't.
Okay.
So if you do it in 5 minutes, we are on track.
Okay.
Shorter papers don't take less time than longer papers. That's the problem here.
So,
No, this is not good.
there we go. So I'm going to start introducing a process framework for global software engineering teams. It's quite an extensive paper, and what they do inside this paper is that they propose a process for global teaming. So more or less a process that kind of aims at making global software development easier and more practical, and kind of reduce the risks. And they developed this this process by looking at having case studies from the period 1999 to 2007, and they also performed 2 extensive literature reviews within the same period. And now from these literature reviews and the case studies, they had set up guidelines or recommendations, questions, so on and so forth, that then forms up this process, which we will look into later. They also evaluated this this process by asking a set of experts on a conference about their opinion about this. The paper asks 2 research questions. What are the threats forced by global software project teams if they do not impose GSD processes correctly? And the other one is, can our global teaming research be integrated in the CMMI model? And the CMMI model is a process model that larger organizations use to promote behaviors that has a positive impact on the performance of the organizations. In this case, it's global software engineering, so it's more at making people understand each other better so they can actually incorporate when you have a distributed team. And the conclusion of the paper is more or less a better understanding of global software development and how you should manage global software development projects. And also, they say that in the end, it's kind of the research that we have on this model that we propose is not sufficient enough, so we should do more extensive research and case studies to actually say whether or not it's good or bad. So, as I mentioned earlier, they had true literature reviews, and up from them they had also 2 case studies where they take a few examples, and one of the things that they discuss a lot about in the beginning is fear and how this has an impact on how people cooperate on the global software development projects. And in the first case study, there was an issue with the 2 teams that were distributed, where the first team was starting to build up a lot of fear, which then created these barriers towards the other team, which created, it literally broke down the communication channel between the 2 teams, and that created this them and us culture, which is what we refer to, because then when you have this them and us culture, you are sort of your own team is very isolated from the other one, and you don't have a clear understanding of what's going on there, and you start to alienate the other team in a sense, and this is derived then again from fear. And then you have the other case study where the first team got scared of losing their jobs, so they started highlighting all the mistakes that the other team made to the senior management to sort of create fire within the organization. And then the other team sort of responded in a similar manner, so we had this tension between the 2 teams, and ultimately this led to that the project failed, and there was no more of that project. And this is, again, fear is a common property that they discuss a lot, which is the common one in these 2 cases that they look into. So they say that in order to have a proper global software engineering project, you need effective technical support, team selection, clear definition of roles and responsibilities, proper skill management, proper process management, reporting on information management, and understanding of cultural differences. If you don't have this in place, there's a large chance that your GSD project might fail. They also discuss this model to the right on the presentation slide, where it's a bit hard to see, but the idea is that you have 2 teams, and then the distance creates this entity called barriers and complexity, which means that you create, for example, communication barriers, so cultural barriers, and so on and so forth between the 2 teams. And distance can also have an impact on coordination and visibility and communication and cooperation, which then again impacts the barriers and complexity. And they argue that although this is one way to look at it, it's not sufficient for all the issues that comes out from GSE in general, because there are also several other issues which this model does not cover. They also start establishing what the potential threats may be within a GSD project, and then they talk a lot about the size of the global team, where, for example, if you have just a handful of people working locally in your own company, and you have around 50 or 100 other developers in India or somewhere else, they might start thinking that they might soon lose their jobs because all the work in their head is happening somewhere else. And then they get this fear again, which then might have a negative impact on how they work. Also, understanding how social, cultural differences work, and understanding the limits of people's capabilities. For example, in some cultures, saying no to a task might be a big burden, so they might say yes to a lot of more work than they initially would do in their projects. And then they get overworked and they might quit their job because they don't feel qualified enough to actually commit that amount of work which they're not capable of. And then you have this issue of knowledge transfer where they lose an important worker on your team, which then has a lot of information about the system and what they're working on and so on and so forth. And then it starts falling apart when that happens. Also, you have the cultural needs and differences. For example, in some cultures, it might be difficult for men to work together with women in certain cases, and other cultures might see rewards as insulting or not the intended way that the reward was supposed to be. For example, money isn't always a good thing in every single culture. Some people might be, nah, I don't like this, and so on and so forth. Yes, then I think it's
Be quick.
Yeah.
We are already 6 minutes over time. So
Yes. All right, so I'll try to.
because we don't need to go into the details about the CMMI.
So Martin basically explained, like in their research, they tried to identify this global software engineering factor that have a great impact on the global team in general. And so what they do in order to validate their GSE factors, they also use the CMMI model, which is a standard model for measuring the performance on the global teams. And so they try to fit all the GSE factors inside the CMMI model, and so that's why they identified 3 categories of how some of the GSE factors fit into the CMMI model. And the first one is, for example, that the GSE factors for which there are explicit processes and areas in the CMMI model. And as on the research, they only find, I think there were only 3 GSE factors that were explicitly mentioned in the CMMI model. And those factors are, I think, process, project, and risk management in general. Whereas for GSE factors, which there are implicit processes defined in CMMI model, they found in total 10 of their factors. But the interesting part is that and there were some factors that were not mentioned in the CMMI model, which, for example, they mentioned skills management. They say that the skills management is not mentioned at all in the CMMI model, where in their research they say that skills management is very important because remote managers or local project managers, if they don't have a clear understanding of their team skills, they might distribute the work differently in each of the site, and this will result to team members to have a lot of work to do without correctly assessing their skills. And because in some cultures, as Martin explained, in some cultures it's not okay to say no, for example, to getting work to do. That's why people tend to get the issues or the task to be completed, and instead of saying no, they prefer to leave the company, and that's why this has a great impact on the development process. So that's why they come into the conclusion that the CMMI model is not enough for global software development teams. So that's why you need another complementary model that will try to fit the gaps of this general model. So that's why here, as you can see, they have the global teaming idea, and they try to split this into 2 specific goals, which for the first one is, for example,
how you define global project management, and the second one is how do you define management between locations. So this mainly happens on the project initial phase when you allocate the task, when you initiate the communication channels, the sites, and then afterwards, when the project is ongoing, then you try to fit all these best practices that they identified during their research review from 1999 to 2007. So at the end, they try to categorize all these factors into 4 main categories, which is basically distance, human factors, management, and infrastructure. I plan to go on some of the basic factors, but yeah.
I think time is more running out.
Yeah. So
Okay.
that's it.
Yeah. I think
Any questions? Yeah.
No, I think again for these papers, it's as I was saying for next rounds, we try to look at what are the take homes here. I think the categories and being aware of the categories here definitely makes sense.
Yeah,
And
this was it was a lot of like parts on the paper where it would be nice to discuss.
Yeah.
Too, because like a lot of cultural factors and communication.
We're going to coming back to cultural. So
Yeah.
anything that goes to culture going to be for not next one, but the seminar after. So we're going to dive into in more detail. Okay. Thank you. Sorry for rushing, but the disadvantage of having 3 papers is that each one take a little bit more than the time that we run out of time. Okay. Thank you.
Thank you.